This week we are covering exception handling in C#, and exceptions are basically runtime errors that you should not be able to predict ahead of time. If you can predict that there could be an error ahead of time, then you should, code up some preventative uh, measures in your code so the error doesn't occur. Runtime errors are things that you can't really predict, and it might be, something that the user inputs that's wrong, or you might have a logic problem that you didn't catch, or it could be a system error, like you're out of memory, something like that. But these errors, when they occur, they terminate your program. And so exception handling allows you to detect the error, to display a message, and to allow the program to continue running. So the program will not terminate. And the mechanism that we use for this is called try catch. And try catch is used in many different languages, not just C#. So what you're learning today, you can apply to other languages that you'll be working with in the future. So how we code these is that any code in the program that could cause an error, you put inside a try block. And a try block is simply the keyword try with a curly brace. And then you've got all of the code that could cause the error. And then you have a closing curly brace. So that is basically saying to the runtime.net program that watch these statements to see if they generate an error. Okay? If they do generate an error, what happens is they look for a catch statement or a catch block that matches the type of error that occurred. So right below the try block, you will code at least one catch block, and you will have the type of error, and you may create an object, or you could create a variable for an argument that you're passing. And you'll see examples of both. But in the catch block, you usually display some kind of an error message. Okay, that is considered handling the error. Okay, and as long as you have a catch block, the program will continue running. A finally block is not required, and I don't normally use them unless I have opened a resource that needs to be closed. So in my try block, if I open a file and I'm reading from the file and there's an error, the catch block is going to handle the error, but that file is still going to be open. So in the finally block is where I would put the statement to close the file. Okay, so unless you are opening resources that need to be closed, you really aren't going to have a finally block. And the way that the exception handling is processed is that everything in your try block will execute up until the point that it reaches an error. Once the error is encountered, it looks for the correct catch block to handle the error. Okay, and then once it's done with the catch block, if there is a finally block, it automatically executes the code. And then if you have additional code below the finally block, that code will run. If there is no error, okay, so it runs through the try and there's no error. Well, awesome. Okay, it's not going to do anything in the catch blocks, but it still will run through the finally block. So be aware that if you code a finally block, it will always execute that code, whether there's an error or not. Okay, and that's why the finally block is optional. So one very common error is a divide by zero. And you'll find that C# has a lot of exceptions that are built in, exception handlers that are built in, and divide by zero is one of them. And so that means that C# is kind of wired to detect a divide by zero issue. And when it occurs, it flags it as an error and it will display a message and it'll say unhandled exception. Okay, because we don't have this inside a try-catch block. Okay, so it's saying, hey, this is an unhandled exception and you've got to divide by zero. Okay, so the minute we try to divide by zero, that error is flagged and we get this message and the program terminates. So here is what exception handling can do for you. So this is kind of the same code or the same program, but now inside the try block, we have that division that is going to create the problem. Okay, it's going to create the error. And then we have a catch block that is specifically looking for a divide by zero exception. Okay, so if a divide by zero exception occurs, it's going to run through the catch, print out the message, and then it's going to continue and execute, the next line below the try catch. And so this is how it looks. It says exception occurred because it detected the divide by zero, went down here, printed the message, and then it went on to complete the program. So it's not saying that it's unhandled. Okay, this is a handled exception. There was a problem, we handled it, and it allowed the program to continue running. And that is the beauty of exception handling. So here is the same program again, but now we have a finally block, just so you can see how that comes into play. We don't need a finally block here because we are not opening any files, but I put it in just so you could kind of see how this, works with a finally in here. So again, it's going to detect the divide by zero. It's going to throw that divide by zero exception and the system throws that. So then we're going to come down here and we're catching it and printing out the error message. Because we have finally, it's then going to go to the finally block, print out this error message, and then it's going to execute code that's below the finally block. And that is exactly what it did. So here is an example, because I think that it's super useful for you guys to see lots of examples so you can get a feel for how all of this works. And so inside the try block, I have all of the code that could possibly go wrong, okay? All of the code that could cause a problem, okay? And then I just am using exception, which is more of a generic exception handler. So if you have exception, it will actually handle all of the exceptions. And the reason I used this is because I am handling some of the issues through a while loop. So I'm having them enter a whole number greater than zero. Here is where I'm reading it in. I'm using try parse. And so that actually returns true or false. So if it returns a bad value, they're going to have to keep re-entering. And a bad value is anything that's not a number. Okay. So what happens if they enter a valid number is it actually puts the valid number into number one, which I declared up here. Okay, so we're reading from the console, and as long as it's a good number, it outputs the number and it's done. If they enter text or garbage, then they're going to get this prompt and they're going to have to keep re-entering until it's a number. It's not checking to see if it's greater than zero, okay? It's just making sure it's a valid number, okay? And it's doing that for number one and for number two. So when we get down here, we at least know that we have numbers. Okay, and what we're checking here is to see if they are less than 0. Because if they're less than 0, then what we're doing is if number 1 is less than 0, we're setting it to 1. So we're putting a valid number in there. If number 2, if number 1 isn't less than or equal to 0, then the problem was number 2, because up here, it's only going to come in here if one of these is 0. So if it's not 1, it's 2. So we set that one to 1. And then we throw an exception. Okay, and this is just saying enter a number greater than 0. A default of 1 will be used. Okay, so that tells them, hey, they did some bad input, but we're going to continue running. This little error message is picked up here. And then that message that we have, okay, so that ends up being the argument that gets passed, and it gets printed right here. Okay, in the finally block, that's actually where I am doing the division because it's going to always run. So it was actually a useful way to use finally, because if there is no error, well, then I've got valid numbers. And if there is an error, I put valid numbers into number 1 and 2. So I know that no matter what, it's going to come in here and it's going to work. Okay, so finally it's doing the calculation, and then below finally, we're just saying have a great day. So we can actually run this if you guys want to see. All of this you should be able to copy and paste right into Visual Studio, and you should be able to run it. Okay, so enter a whole number greater than 0. So first I'm going to enter garbage because this is the while loop. Okay, so it's not going to get past this until I actually enter a number. So let me do 50. Enter a number greater than 0. So if I do a negative number, right, that is not going to flag the garbage error like this did. Okay, but I did a negative number. So where that gets picked up is right here. Okay, that less than or equal to 0 code. So system exception, please enter a number greater than 0. A default of 1 will be used. So it took 50, which was good, divided by 1. So number 2 was the negative number, changed to 1, is 50. Okay, so it still did the arithmetic and it still finished. So we handled the issue. The program was allowed to finish. We gave it a different value that worked for the division. Now, depending on the code, you may end up needing multiple catch blocks. In your try block, if there is the potential for different types of errors, then you're going to want different catch blocks. So if you have an array and you're indexing into the array, there is a potential for an index out of range. Anytime you are doing division, there is a potential for a divide by 0. Okay, and then exception handles everything else. So if you are going to code multiple catch blocks, you go from the specific, which is the exception that you know, index out of range, divide by 0, those are specific. You do those first, and then the generic one comes last. And it doesn't matter if you do divide by 0 or index out of range, which one comes first, okay? But it does matter that you do the generic one last. So here is another example. And in our try block, again, we're making sure that at least they enter a number. Okay, so they aren't entering text for the number. And then in our console.write line, this is where we're actually doing a calculation. And this is where, we could get into divide by 0. And anytime we're subscripting into an array, there is a possibility of going beyond the ends, beyond the bounds of the array. Okay, so this line is really the one that could create the problem for us. So we have a catch block that says index out of range. We have a divide by 0. And then if anything else happened, we have the generic. Okay, and so you can also run this one. And this one actually does something interesting. So here, when we run this, we are depending on the system to throw the error, right? The system is detecting it. We have not, done any coding to check, to see if the second number is going to be 0 or not when we're doing dividing. So let's take a look. It does a pretty good job of detecting the out of range. So if I do like a 10 here, it's not going to detect it yet because we haven't gotten to the line where we're subscripting in. But it's going to detect it now. And it says you are indexing beyond the bounds of the array. Have a great day. So it didn't calculate anything because it couldn't, right? So let's do this. So let's do, if we do a 1, okay, then the way this is coded, they have to enter a 1 through a 6, although this is technically index 0. So what we've done is we've subtracted 1 for the actual indexing in. Okay, and we're displaying 1 to 6 to the user because users don't understand 0 to 5. They're like, why would I enter an index number of 0? Okay, so this is just to make it more user-friendly. So technically, if I do the second number and I have a 1, it's going to grab the 0 and it should be flagging division by 0. So let's try 5 and 1. And you'll see it did not flag the error, which is crazy. And if I do this, if I do a 1 here and a 1 here, it does. So sometimes the system does not always detect the exception. And so you will see in the next example, we can actually look for those problems and detect them ourselves, and we can throw our own exceptions. Okay, and we're going to get to that in a minute. Just wanted to point out that so far to catch any generic exception, we've been using this catch, and then we've just had exception. Another way that you can catch all exceptions is just using the keyword catch. Okay, either one of those methods is considered a generic catch block. Now on to throwing your own exceptions. So, you can look for error conditions and you can throw your own exception. So that program we were just looking at where it did not detect that the second number was a 0 in all cases. So we can actually add a little if in here to check that second number to see if it's a 0, and then we can throw our own divide by 0 exception. Okay, so we can add that in, and then we can do the calculation like we did before. And that way, divide by 0 is going to work. So let's run this one. So we're going to do the same thing we did before. We'll do a 5 here and a 1. Okay, and this should detect the divide by 0, and it does. Okay, so we kind of took matters into our own hands here, decided to check on it ourselves. We are throwing the exception, okay, and that works. So that was an example throwing a very specific exception, right? Divide by 0. You can also throw generic exceptions. So if I had the same program and for some reason I had some kind of business rule where I didn't want the numbers to be the same. Okay, so if I'm subscripting in and let's say it's 10 and that is equal to 10, okay, I don't want that. Okay, I want it to do a division with different numbers. I could throw an exception here that's just kind of a generic one. And you can see here is the generic catch, and it's just going to say an exception has occurred. Not a particularly useful exception message, but we can actually run this. We don't want to run quite that much. Actually, I'll just add this to the code that we have. I'll throw that in up here. And do we have, yep, we have the generic one in there already. So let's run it. All right, so if I did, okay, so you can see that it's showing us the exception has occurred. Have a great day. So it did catch it right here. So we have another example. And what this one is doing is that if there is a problem, if they did enter some bad data, we are setting default values. Okay, so right up here we have a static method called calcrate. And this is going to calculate a target heart rate. So we are receiving the age and the resting heart rate. And if they did an age that is out of range, we're going to set it to 50. And we're just going to throw a little exception indicating that the age they entered is out of range and that we're using 50 instead. And here we're checking the heart rate. And if that is out of range, we do the same thing. Use a resting heart rate of 50, and we're going to display a little error message that says that their resting heart rate was out of range, and we're using 50 instead. And then you can see we've got our try block, we've got our catch to handle that message. And then below that, because we set those default values, we can go ahead and calculate their training heart rate. We're storing that in message, and then we're returning that. So the program can continue running even though they gave us what I would consider bad data. Then in our main method, we've got age and resting heart rate. We ask them to enter the age. We basically ensure that they've entered a number. Okay, and then we do the same thing for resting heart rate. So by the time we get down here and we call calcrate, we know that we have two valid numbers. Okay, so when we get up here, the only thing we have to check is the range of those numbers. Okay, and so this actually does work, and this is a valid heart rate calculation, just so you guys know. Okay, and so we will go ahead and run this. Enter your age. Well, I'm just going to say I'm 29. Let's see, resting heart rate, say 45. So this is all valid. Okay, so this training heart rate is fine. They didn't have to use defaults. So now let's do something that's outrageous. What is your age? 150. Resting heart rate. 0. Okay. So age is out of range. Default of 50 has been used. Okay. Let's see. And then they did a calculation on that. Let's run it again. Enter your age. Let's see. I can see one thing that we probably need to fix. $52. Yeah, so I guess it is possible that they mess up age and resting heart rate. And because they're throwing the error here, they're not going to get the default of 50. So I'm going to fix this right here. I'm just going to say no, resting heart rate doesn't equal age. We'll have it equal 50. There. All right. That takes care of that issue. All right. So if we did 150 here and we did 150 here, okay, so that way it's using 50 for both. Okay. So you guys kind of get the idea there. That brings me down to rethrowing an exception. Why would you need to throw an exception that was thrown? So if you have a method and you detect an exception, you may want to, in your catch, simply throw it back to the program or the method that called, the calling method. So here's an example of that. So I've got something called math method. This is a static method, and it's receiving two numbers. And so we're checking for a couple different error conditions. Okay, and it doesn't matter really what the error is, because what the catch is doing is it's throwing this back to the main method or whatever method called it. Okay, and that method can handle the problem. So it's basically passing the buck. Okay, so here is the full program. Okay, so here is the main method. And here you can see that it's calling math method, and we're passing two of the numbers that we subscripted into. And so, at this point, if it's out of the index out of range, it's going to catch it. Okay, but it's not going to catch divide by 0 at this point or any other kind of error. So it's going to go up here. And if those values are equal, we're throwing the exception. Okay, so that gets thrown. And the block that will end up catching it, because it gets thrown back to this point, the block that'll end up catching it is the generic one. Okay, and then if the second number is 0, we've got the divide by 0. So that gets thrown to here, and we're passing the buck. So that gets thrown again, gets thrown to here where it was called. And so that's going to run through divide by 0. So when they talk about rethrowing an exception, that is what they're talking about. Okay, the fact that in the method is really not handling it. The catch is just throwing it back to whatever method called math method. Okay, so it goes back to the point it's called, and then the catch blocks need to be below that. So we can run this just so you can see how it works. Okay, so we're going to code this. We'll do the divide by 0. So we'll do a 5 and then we'll do a 1. So this is not going to do the out of range because these are valid index numbers. Okay, but it did do the divide by 0. So what happened when it came up to math method is that it had a 5 and a 1. So it ended up passing the 40 and the 0. Okay, and then it came through here, and that second number was 0, so we threw the divide by 0 exception. It caught it here, but it just passed the buck and threw it back to the point it was called from, and then it went to the catch block for divide by 0 and displayed the message. So we've looked at several different examples, and several of them had specific types of exceptions. Okay, index out of range, divide by 0, and basically exceptions fall into two different categories. There are system exceptions where the system detects it, and you saw examples of that. And sometimes the system doesn't do a very good job of detecting the error. And then there's application exceptions where we specifically code to look for the problem. Okay, and up here, we have an example of that, right? So we're looking for a problem here, and we are throwing the exception. That's an application exception. We're doing the same thing here. Okay, and then what we're not specifically looking for is the index out of range. So if it caught the index out of range here and threw an exception, that would be a system exception because we did not specifically check those indexes to see if, they were greater than 6 or less than 0. Okay, and so all exceptions kind of derive from object and exception. And this is kind of the hierarchy of C# exceptions, where you have system exceptions. These are the ones that are generated by the system, and these are the ones that it's looking for. And then the application exception that you create yourself. So you can throw these system exceptions, and you guys saw examples of that, right? We threw our own divide by 0. We threw our own generic exception, and this kind of lists all of them. You can have argument exceptions, null exceptions, argument out of range. So these are all of the different types of exceptions that you can throw or that the system can automatically detect. So it's not necessary for us to write code that detects those types of exceptions. However, you can write code that catches the exception and displays a message. And in the case of divide by 0, where it wasn't always detecting that, you certainly can look for the problem and throw the exception yourself. Okay, and so that's pretty much how we're going to be handling exception handling in this class. You can take it one step further, and that is beyond the scope of what we do in this particular class, but you could actually create your own exception class. Okay, so you can create your own exception class, kind of like the key not found exception or divide by 0 exception. You can create your own class that you could use. And that would be in the next class, the 195, where we would do that type of thing. One other thing about all of these exceptions is that you can create an exception object, and you can do that in the catch. And if you create an exception object, you have access to these properties. And when an exception occurs and C# detects it, it automatically saves information about the exception. And these properties are ways for you to access that information. And probably the most useful is the message and maybe the source, because that would be where the error occurred. So if you wanted to access the properties, okay, the information that C# stores about the exception, okay, in your catch, you have to tell it the kind of exception, overflow exception, or, divide by zero exception, whatever that is. And then you have to give the object a name. Okay, and you're going to use this little exception object to access these properties. So if I wanted to access the message, I would say ex.message. If I wanted to access the source, I'd use ex.source. Okay, so here I've got catch, overflow exception, ex, and here I am writing out that message that C# generated. Okay, so here is another example. We've got an index out of range, divide by zero. E is the object, the exception object, and here I'm writing out the message and the source. Okay, and so here I gave you some sample output just so you can see. I kind of bold-faced the lines that are coming from the catch. So here I've got my message. You're indexing beyond the bounds of the array. And you can see I put in a 10, so that's why we got the message. And then this is the message that C# generated. Index was outside the bounds of the array, which is actually a pretty good message. Okay, and then this is the name of the program. Okay, that's e.source. And then for the divide by zero, my message was you cannot divide by zero. And then the message, e.message, was attempted to divide by zero, which is actually pretty good. And then again, the name of the program that the error came from. Okay, so that in a nutshell is exception handling. Hopefully you guys have a better understanding of how it all works. And you will get the opportunity to practice some exception handling in the Code Easy exercises and the lab assignment.